In this video, we are going to talk about vector subtraction. Supposing I have a vector A pointing in some direction, and let us say the length of this vector A is 6 meters. It's a displacement. So how do we write this? We say the magnitude of A, you put those two lines for magnitude, is 6 meters. Consider another displacement which has the same magnitude but points exactly in the opposite direction. This is also 6 meters long. Is this the same vector as A? No, its direction is different. So we have to call it B. So what we have is the magnitude of B is also 6 meters, but vector A is definitely not equal to vector B because they have different directions. Let's ask the question, what is A plus B? So what do? We have to take one of the vectors and slide it until its tail touches the tip of the first vector. So let's slide B, and now I'm going to draw this in yellow color. Let's slide B and place it so that its tail is at the tip of A, and we draw B, and what happens? We arrive at the starting point. In other words, displacement of A followed by displacement of B is zero. There is no displacement. In fact, that is true of any two vectors if they are of the same magnitude but in opposite directions. When I add the two vectors, that means perform one displacement followed by the other, you come back to the starting point, so the change in the position is zero. So we are going to call vector B, we are going to call it minus A. So that the equation becomes A plus minus A is 0. We can simply write this as A minus A is equal to 0. So the moral of the story is, if you have any vector, let's say this vector, let's call this C, and if I ask you what is minus C, the answer is a vector of the same length but in the exact opposite direction. So this vector is minus C. So now we can use this concept to do vector subtraction. For example, supposing I ask you, here are two vectors, vector A, let me draw that, this is vector A, and let's say that is vector B. So this is A and this is B. Instead of adding them, supposing I say find A minus B. So what should you do? To A, you must add minus B. What is minus B? Minus B is this vector pointing in the exact opposite direction as B, having the same length. So this vector is minus B. So let us go ahead and add minus B to A. So I'm going to draw A again here. This is A. Remember, you can always slide a vector without changing its magnitude and direction. It remains the same. So this is vector A. And to that you have to add minus B. So slide minus B until its tail is touching the tip of A. See, this vector is minus B. Add these two, what do I get? The resultant is this vector, which is A minus B. So this vector is A minus B. It's as simple as that. To A, you add minus of B. Minus of B is a vector exactly opposite to B, but of the same length. This is how you subtract vectors. Interestingly enough, notice that the magnitude of A minus B is actually bigger than the magnitude of either A or B. But that's vector addition for you. Let's do a couple of examples. Vector A is given as 6 meters northeast, exactly at 45 degrees. That is, vector A 6 meters northeast. So this is vector A. And vector B is given as 6 meters southeast. So let's draw that. 6 meters southeast. So this is vector B. Remember, when I simply say southeast, that means exactly in between south and east. So that is 45 degrees, and northeast, so that is 45 degrees. So if I want to find B minus A, what should I do? To B, I should add minus A. So let us draw minus A vector. I'm going to draw that in yellow color. If this is A, minus A is a vector exactly in the opposite direction, 6 units long. In other words, minus A is 6 units southwest. So let's take minus A and add it to B, right? So this is minus A. Let's add it to B. So from the tip of B, draw minus A. If you draw this, you can convince yourself through geometry that it will come and touch the north-south line. So this is minus A. So what is B plus minus A? It's this vector from the origin all the way down here. This vector is B minus A. Let me draw that vector again for you in yellow color. It starts here and ends here. That is the displacement B minus A. Let's do a little bit of geometry. This is 45 degrees. So this is 45 degrees. This is 45 degrees. So that is 45 degrees. That means this is 90 degrees. So we can use Pythagoras theorem. This is 6 units long and minus A is also 6 units long. So the answer is 6 root 2 meters south. Remember, you have to give the direction also. So that is B minus A. Let's do one last example in this video. Supposing we have a particle which is initially moving north at 4 meters per second. So we represent its velocity by this arrow. 4 meters per second pointing north. After some time, we find that the same particle is moving. It's here and it's moving 4 meters per second west. So that is the new velocity. This is also 4 meters per second. If I call this vector the initial velocity Vi, don't forget I have to put an arrow on top to indicate it's a vector. It has a direction as well as a magnitude. This vector, the final vector, is a different vector even though that's 4 meters per second. So this is the vector final. It's a different vector. It has the same magnitude. Now I ask the question, has the velocity changed? The answer is yes, the direction has changed. Vector includes direction. A direction change is also a change in the vector. So I ask the question, why did it change direction? Because someone exerted a force. According to Newton, if no force is exerted, it would have continued with the same initial velocity Vi. So someone exerted a force, there was an acceleration. Is there an acceleration? Yes. Acceleration does not mean change in speed. Acceleration means change in velocity. Acceleration means rate of change of velocity. We'll come to that. But here the velocity has changed. So we have to say the particle has accelerated. And I now ask the question, what is the change in the velocity? This symbol, delta, represents change. Change is always final velocity minus initial velocity. So now we need to do vector subtraction. That is, to the final velocity, we have to add minus of the initial velocity. What is minus of the initial velocity? Minus of the initial velocity is 4 meters per second south. So this vector is minus of the initial velocity. Slide minus Vi and add it to Vf. That means place it tail to tip like this. If I do that, this is also 4 meters per second in magnitude. I get the resultant is this vector 4 root 2 meters per second. In which direction? Southwest. So this vector is V final minus V initial. This vector is minus V initial. So to V final, we have added minus V initial to get V final minus V initial. So the change in the velocity is this vector 4 root 2 meters southwest. Why did this change happen? Because there was a force. We will talk about that in a future video. Goodbye for now.